So this is going to be a long talk. It should be about a 25-minute long talk. I haven't given it in 6 months or so, so I'm not entirely sure what's on the slides. So this will be fun. Um, it'll be fine. I've given this a few times before. I've never given it at this meetup, which is interesting because this is the first talk I've ever given at a conference, and I've never actually given a long format talk at this meetup. I've given 3 talks that are kind of longer form at varying conferences in the last couple years. I first gave this talk last year over the summer, 2016, at DjangoCon. Before I gave this talk, this was my first long format talk, I gave a whole bunch of lightning talks. So this is not my first talk, but I want to kind of make a little pitch for lightning talks here. I gave probably 10 lightning talks at this meetup and another one in town before I gave this talk. So this talk essentially, the reason it is what it is, and the reason it's kind of a half-decent talk is that I gave a whole bunch of lightning talks first. And I kind of glued a few lightning talks together to make this. All right, so we're going to talk about readability specifically in Python. So this is a Python-specific talk here. Before we talk about readability, we need to make the slides not black on black.
I thought that was irony.
No, this is not. This is not meant to be irony, though I should have ran with that. So it's funny. This happened to a friend of mine recently at a conference. I know how to fix this because this has happened to me before. We're just going to not go in full screen, which is a little annoying, but maybe we can do this. Will this work? Is that the magic? That works. That's weird. Okay, so the F key doesn't work. That does work. Wonderful. Readability is the measure of how easily we can read our code. How easily we can read our code. I'm not going to talk, well, before we dive in, we're going to talk about why we care about readability. So readability matters because every time you fix a bug, every time you change some functionality in your code, every time you add a feature, you need to read some code. I'm going to sit down. By the way I do lightning talks and the way I do long format talks, I read off my speaker notes. So that is the reason I'm sitting, because I don't have a podium here. I'm going to read off my speaker notes to you, essentially. Except for the random improvisations, like fixing my slides that aren't readable. Yep. Speak louder? Oh, that's a good point. So, sorry, that AC is a little hard to hear me over. Can you hear me in the very back of the room? You can hear me? Cool. So, you need to read code in order to write it. You need to read code in order to write it. Every time you change something, you need to read code. Also, teams tend to turn over. Not all teams are immortal. You will need to hire people. People do leave. People get fired. When you need to onboard people, they need to read your code. The more easily they can read your code, the more easily you can onboard people into your team. This is an efficiency problem. So we are not going to talk about how easy it is to write code. We're not going to talk about how easy it is for a computer to read your code or to run your code. We are assuming that source code is primarily meant for human consumption during this talk. So outside of this talk, we can talk about efficiency. We're talking about human consumption of code. And Python is largely a language meant for human consumption. So we will talk about how to structure your code. That basically boils down to where you put line breaks in your code. We'll also discuss unnamed things, naming unnamed things, and naming things descriptively. And lastly, we're going to consider some of the programming idioms that we use pretty much every day in the Python world. So we're going to look at a lot of small code examples. These slides are already on the internet. You might have seen the URL as I full screened it there. It's treyhunner.com/readability-counts. And I'll link that on Meetup as well. So we're going to talk about structuring our code first. In the modern age, line length is no longer a technical limitation. Screens are really wide. Line length is not a technical limitation. It is about readability. Long lines are hard for the human eye to read. Line length is a little bit flawed as a metric. It's only an approximation of something that actually improves readability. Short lines are often more readable. When discussing line length, you should remember that our end goal is not short lines, it is readability. We're talking about the length of a line because shorter lines are often easier to read. So when you're inserting line breaks, make sure that you're focusing on readability, not line length itself. If it doesn't make your code more readable, you're not actually achieving your end goal. Okay, so let's take a look at an example. This code has a line length that is under 60 characters. This is well under the 79 characters that PEP 8 recommends, PEP 8 being the Python style guide. We'll talk about that in a little bit. At least I think we will if I remember these slides. As you read this code, you are probably trying to figure out what this does. If you've seen a generator expression or a list comprehension before, you might eventually figure it out. That first line of code, it has a generator expression with 2 for loops inside it. That second line, it is a generator expression with a single loop and a condition as well. This code is hard to read because the line lengths were inserted completely arbitrarily. We approached some kind of maximum line length and then we wrapped the line. So the author of this code was thinking about line length. They were thinking about line length, they weren't thinking about readability. This is the same code, but we've moved where the line breaks are. The only thing we did was move the line breaks around. So is this code more readable than what we had before? Yeah, quite a bit so. So this is the same code as before. We shuffled the line breaks around and inserted them not arbitrarily, but with the specific purpose of improving readability. So we broke up each of the logical sections of this code block here. Okay, let's take a look at another example. This isn't a Python-specific example. This is regular expressions. So if you haven't seen regular expressions before, you should feel lucky, I guess. If you have, you know what I'm talking about here. This is a regular expression. It returns true if the string that it was given is a valid, universally unique identifier, valid UUID. I'm not going to talk about what that is. It doesn't really matter. It's a complex thing. So it's validating UUID strings. This code is kind of difficult to read here. Even if you know what regular expressions are, it's a little bit difficult to parse this. So regular expressions are code. They're not Python code. They're kind of a mini programming language inside of a programming language. So regular expressions are code, but we tend to write them all on one line without white space or comments. Who writes their Python code on one line without white space or comments? No one does. We can't actually do that. It's not even possible if you wanted to. As many semicolons as you put in your code, you're not going to be able to put those for loops and if statements all on one line. Okay, so you don't write Python code this way. You can't write Python code this way. We do write regular expressions this way. When using regular expressions, in Python, you can enable verbose mode. Verbose mode allows you to wrap your regular expressions over multiple lines and insert comments if you want. So it ignores white space. It allows you to ignore white space in your regular expressions, which means you can make your regular expressions more readable by inserting white space and inserting comments. So when using regular expressions in Python, always turn on verbose mode. This is called X mode as well. It comes from the Perl world. Perl also has X mode. JavaScript doesn't. A lot of programming languages differ on how much they support this. Python does support it. Okay, let's take a look at another example. So we're gonna create a Django model here. A Django model, and our model has fields that take a whole bunch of arguments. So this is a foreign key field. If you've never done Django before, it doesn't really matter what this is doing. This is making a foreign key field on a Django model. It's calling a function, or rather a class here called foreign key, and it has a whole bunch of arguments. So we're passing a lot of arguments to this foreign key thing. It feels a little unwieldy. Is this a good way to wrap our code over multiple lines? So it works. I mean, it's pretty readable here. It could be worse. Is this better? Is this better or worse? Better. So I see some head shaking, some head nodding. What about this one? Is this better or worse? Okay, so would anything change if we were using exclusively keyword arguments? Does that change your opinion at all? Does it matter? So personally, I usually prefer the last one of these three here. I mean, I'm kind of primed of here to like the last one because I showed you these in a particular order here. That first one I find difficult to read, especially when we have long, or rather that second one actually is the one that is especially difficult to read when you have long lines. That first one I find difficult to read in general because there's kind of a lot of arguments all shoved on one line together. So I'm going to focus on that third one. So if we're using this strategy of wrapping our lines here, would it be better to leave the closing parenthesis on its own line? Does this improve readability at all, or is it better to do that first one? If we do this, should we add a trailing comma? Or should we not add a trailing comma? So this is the one I prefer. You might not prefer this one, but it's okay if you don't prefer this strategy of wrapping your lines. The important thing when you're wrapping lines of code in Python is to make sure that you have a style guide for every project that you create, and you document the way that you wrap your code in every project that you create in that style guide. Who has a style guide for every project you make? So I'm not raising my hand because I don't follow my own advice here. I try to make style guides. It's hard to do. I'm going to do questions at the end. That's just for the sake of time. If you do have questions, I don't know, write them down or try not to forget them. So consistency lies at the heart of readability. Be consistent, make a style guide, document the way you are wrapping your lines of code in that style guide so that other people can abide by your style. When you're contributing to someone else's project, you want to abide by their style. When they're contributing to yours, you need to set the rules for your own style guide. If you're on a team, you've got to define this as a team. Okay, so talking about style guides, PEP 8 is the Python style guide. If you are not familiar with PEP 8, you should read PEP 8. If you are already familiar with PEP 8, reread PEP 8 every 6 months or so, and you will learn something new, I guarantee it. I've read PEP 8, I don't know how many times, and every time I see something else in it that I'm not doing in my own code, because there's a whole bunch of recommendations in PEP 8. Or I see some things in PEP 8 that I am doing, but I'm not particularly consistent on. Sometimes it gives you 3 different ways to do the same thing, and it leaves up to you which way is the best way. So PEP 8 is the Python style guide, but it is not your project's style guide. It is a foundation to build up from. You need an opinionated style guide. PEP 8 is not opinionated enough for your project. It's simply a starting point. It doesn't usually tell you the exact way you should do things, the one true way to do things. It says these 3 ways are pretty good, these 3 ways are not so good. You need a style guide that says exactly how you do things in your project because you want consistency. Okay, so a little bit of a recap here. Remember I said lightning talks are where I'm coming from, so I'm going to have little minor recaps throughout these sections here. Poets do not wrap their lines when they had a maximum line length. That would be ridiculous. There are actually poems that are kind of that way, that have a maximum line length. Most poets don't wrap their lines at a maximum line length. They insert their line breaks with purpose. The purpose of readability and maybe artistic merit in mind. So in poetry, inserting a line break is an art form. In Python programming, inserting a line break is also an art form. So as programmers, we should wrap our lines with great care. And remember that all of your projects should have a style guide that goes beyond PEP 8 and also dictates how you differ from PEP 8 and where you go beyond PEP 8. And your code style conventions should all be explicitly documented in your style guide. I'm going to drink a water real quick here. So the next thing we're going to talk about is naming things. If something is important, it deserves a name. Names give you something to communicate about. Unfortunately, naming things is hard. Naming a thing requires describing a thing, and describing things is not easy in itself. Not only that, once you've properly described a thing, you need to shorten that description in order to make it into a name. If you can't think of a good short name, use a long and descriptive one. A long and descriptive name can more easily be shortened later than taking a short name and lengthening it later. It is a lot better to have a long and descriptive name that's annoying to type than a short subpar name. So when naming things, worry about accuracy, not about the length of your names. 20, 30 character variable names, not the end of the world. You can always shorten them later. Make it descriptive first. So let's take a look at some code that has some poor variable names. We're going to look at some code that has variables, but they can be improved in their names. So what does SC stand for? Anyone want to guess?
Source control.
Source control, that's a guess. Any other guess? What could SC stand for? Separated commas, maybe? South Carolina? Sour cream? Does not stand for any of these very valid things. So if you had more context, you might understand what SC stands for. With just this bit of code, you need to go searching around for context. So ST stands for state capitals. Don't use two-letter variable names in Python. Use descriptive names. Speaking of descriptive names, what does I represent? An index? It doesn't represent an index. We're indexing it, I sub 0, I sub 1. What's I sub 0? What is I sub 1? Is I sub 0 states? Is it capitals? We don't know. We don't know what the significance of these things are. Hopefully one is states and one is capitals at least. When you see an index access, I sub 0, I sub 1, that should be a red flag. This is an opportunity for us to name some variables using tuple unpacking. So you could probably now tell that S and C mean states and capitals. That asterisk underscore thing I can explain later if you're wondering what that is. It's a Python 3 thing. We can use tuple unpacking or multiple assignments to assign variables that might not otherwise have a name. This I sub 0 and I sub 1 now are S and C. Now S and C are still not the greatest names. We could have called these state and capital, but it's better than an index. You can at least guess what we're going in the direction of there, what they might represent. So there's no reason not to use real words for variable names here. Take this a step further and use actual names here. Name all of your variables with care and optimize for maximum accuracy in your variable names, and completeness, not for the ease of typing your code. You type your code once, you read it lots of times. Don't worry about short variable names. Okay, so we're going to look at some code that could use some more variable names. It is missing variable names. So this code returns a list of all anagrams of word, that argument word that is coming in, which are in the candidates list. So all anagrams of the word that happen to be in that candidates list. This is not bad code, but it is not the most descriptive code. You kind of have to read this whole thing to see what the algorithm is actually doing. So that if statement in particular kind of has a lot in it there. So if we abstracted out this logic into our own function, this might be a little bit different. We're going to look at that function in a moment, but I'm just going to pretend we have a function called isAnagram. It takes a word, it takes a candidate, a single candidate word, and tells you whether or not it is an anagram. It returns true or false. So we've broken down the problem here to describe what the process that we're using is. We've kind of hidden the details of the process. We're describing the process. So we're going to take a look at that isAnagram function here next. So this is pretty much exactly what we had in our if statement before. We haven't improved anything yet here. We have given a name to our process isAnagram. We haven't improved the actual code inside though. So word1.upper appears twice. Word2.upper appears twice. So we have a little bit of code duplication. Let's fix that first. This is a little bit better. We've shortened it kind of to one line of code here. We're sorting the words, and then we're checking to make sure they're not equal to each other. So I find this a lot easier to read. I do think there's still some room for improvement, though. This one strategy that I use when I'm trying to decide whether my code is clear enough is to read the code aloud. So here we are sorting our words, and we're checking whether the sorted versions of our words are equal. And then we are checking whether the unsorted versions of our words are not equal. This is still pretty nitty-gritty. That's not really the way we talk about in English, checking whether something's an anagram. So we could write comments that describe the intent of our code a little bit better here. So we've added two comments here. If we ignore the code and just read the comments, you'll see that we're verifying that the words have the same letters, and we're checking that they are in fact different words. Whenever you find yourself adding comments to your code, this should be a red flag of sorts. Not that your code's wrong, but that you might have an opportunity to make a better variable name, to improve a variable name, or to create a variable name that didn't exist before. So comments describe things, and variables describe things. Variables take a description and put them into code. So we're going to turn those comments into some descriptive variable names. So we've turned those two conditional statements that we had before into two variables that describe what those conditions actually do. That last line literally says we are checking whether these two words have the same letters, but they are, in fact, two different words. That's exactly what our comment said before, essentially. So those two new variables that we've got have same letters and are different words. These made the logic of our code, they kind of abstracted the logic of our code out and allowed us to describe our algorithm itself, describe what our code is actually doing. I think this code is more clear and more readable because we're conveying the intent of our algorithm and not focusing on the details of the algorithm so much. Okay, so I'll do questions at the end. We ended up adding 4 extra lines to this code, but we broke down our process, the process that we're using to find these algorithms a little bit, to make our code a little bit more understandable at a glance. Someone can glance at this code and from the variable names hopefully understand a little bit about what it is that we're doing. So you might think this is a pretty silly example. What we had originally was not actually all that unreadable. Is it really worth the time to go through this process? So even if we decided to revert a couple of these steps here, this mental exercise is still worthwhile because you're going to read this code a lot more often than you're going to write it. The exercise of refactoring your code or attempting to refactor your code to be more self-documenting can reframe the way that you think about your own code and can change the way you think about your own code to help you hopefully think about it in a way that might be more descriptive or might allow you to write it in a more descriptive fashion, even if you're going to revert some of those steps, if you do take it too far sometimes. Okay, so one more example talking about variable names here. We're going to take a look at a Django model method that is pretty complex. So this function is a method that lives in a Django model. There's a lot of code in this method. Instead of reading all this code, I want you to unfocus your eyes and focus on the structure of this code. So eyes unfocused. I can talk about this code without you getting distracted now. So the first thing you will notice is there are 3 blocks of code here. We have line breaks in between 3 sections of code. We broke this code up into 3 sections, presumably because each of these sections has a purpose. They're doing 3 steps. So we're going to add some comments above these sections to describe what it is that they're doing. So at this point, adding those comments, in my opinion, already improved readability because we can skip the code and read the comments in many cases. We can understand, even if we don't understand anything about Django, what it is that we're doing by reading those comments. We're writing a recipe that says, this is what our code actually does under the hood. So depending on why you're reading this code, you might even be able to skip over the code itself and just read the comments. Okay, so I mentioned this before. Comments are sometimes a hint that you've forgotten to make a variable name or you've named something poorly. So we could name some things here that are unnamed. We have comments that describe each of these 3 sections. We could name each of these 3 sections of code. The way we can name a block of code is to make another function. So we're going to turn these comments into variable names by putting each of these blocks of code into its own method in our Django model. So here we've named each of these 3 sections of code by making them separate functions. I put an underscore before the variable names. That's a convention. You can name these however you want, as long as you're giving them a descriptive name. Now notice I haven't deleted the comments. I turned them into documentation strings. There's no reason not to document each of your functions. Doc strings are better than comments because they can be picked up by tooling that allows you to turn your document or turn your code into documentation, to something that actually can be read by someone who isn't necessarily looking at the code itself. So I've left those comments in. We've made 3 separate methods. We need to call these methods though. So in our original method, this is all we have now. This code is pretty descriptive. We've hidden all the details in these 3 separate methods. So I find this code a lot easier to digest than 3 blocks of code without much context at all, especially before we added those comments. So we've named each of the 3 actions that our code was actually doing. And most of the time, we probably don't have to jump into those methods. We're probably looking for the method we're looking for, and then we dive into one of those 3, and not all 3 of them. All right, so a little bit of a recap here. The section we just went through, read your code aloud. to make sure that you are describing the intent of your algorithm in detail and not just leaving the details of your algorithm out there exposed. Remember that comments are great for describing things, but sometimes comments are just the first step towards making a better variable name or naming something that has not yet had a name. Make sure you give a name to everything, and in general, strive for descriptive and self-documented code. Okay, we're going to talk about some of the code constructs that we use pretty frequently in Python. So there's usually multiple ways to write the same code because there's often multiple tools to solve the same problem. So even in Python, where there should be one and preferably only one obvious way to do things, there are usually multiple ways to do the same job. That's just a part of programming itself. So when given the opportunity, I often tend to prefer special purpose tools over more general purpose tools, as long as the tools themselves are easy to understand. So in my opinion, specific problems call for specific solutions. Special purpose problems call for special purpose solutions. So we're going to take a look here at some exception handling. So we are opening a database connection, reading from the data in that database connection, and we are closing our database connection. We need to make sure that our database connection always closes, which is why we have a try finally there. If you've never seen a try finally, that finally always gets executed regardless of whether an exception occurs. When you have code that is wrapped in a try finally or wrapped in a try except or has some kind of cleanup step, I want you to think about whether you should use a context manager in your code instead. So it's not too hard to make your own context manager. This is how you'd implement that in a class. You need some dunder methods, a dunder enter, a dunder exit. If you don't know what dunder stands for, dunder is double underscore. So underscore underscore enter underscore underscore, that is a dunder method. I want you to ignore this code. This code is irrelevant. The code that's relevant is what we're doing to use this code. This is how we use a context manager. We write a with block. So this is a little bit simpler than the try finally we had before. As the reader of this code, we don't have to worry about whether our database connection is being closed. We know it's being closed because the connect context manager does that for us. We don't have to worry about that detail. So this is pretty nice. We've abstracted away the problem of closing the database. It always gets closed when we're using a context manager. So we don't always have to write our own context managers though. If you're using Python 3, you can use the closing context manager built into the standard library. We can wrap our database connection in that. It automatically calls the close method on that. Same with files. Anything that has a close method, you can use the closing context manager. So whenever you have a cleanup step, I want you to think about context managers. These are special purpose for cleanup steps in your code. You can probably find a context manager that fits your use case. If you can't, you can invent your own if you need to. All right, let's talk about for loops. So this code loops over something. This code is blurred out, but you can probably tell that it loops over something because I've got a for, an in, and a colon that are not blurred out. This does a little bit more than just looping over something though. Specifically, the purpose of this code is to loop over something, check a condition, and create a new list from items that pass that condition. So we're using a list append, an if statement, and a for loop to accomplish this task here. There is a better way to write this code. We are accomplishing the same task as before. Instead of making a for loop to take an old list and make a new list, we are using a list comprehension. So this code isn't shorter than what we had, but it does contain less unnecessary information. It contains less noise. So there's less unnecessary information here for our brains to process as we're reading this code. When we glance at this code, we don't think looping. This code doesn't have a for loop inside it. We think instead one list is being transformed into another. That is the purpose of a list comprehension. The sole purpose of a list comprehension is to take an old list and turn it into a new list. So that is a better description of what our code is actually doing. We don't really care about the looping, we care about transforming an old list into a new list. When you have a specific problem, use a specific tool, use a special purpose tool. If you're making an old list from a new list, don't think for loops. Reach for list comprehensions if you can. All right, another example here. We're going to create a class that represents a shopping cart. So if you haven't seen classes before, this is going to be a little bit of an overwhelming example. This is a shopping cart class. It's a wrapper around a dictionary. Now, I don't have any code in here. There's no code in this class. You're going to have to imagine there is code that works. I removed it for the sake of this brevity of this slide. This class implements a lot of methods that really just access the dictionary that's under the hood in a fancy way. There's methods to check for containment, to add things, to remove things, to check quantities of things, and ask questions about the status of our shopping cart. These methods might seem a little bit familiar. All of these methods correspond to operations that work automatically on many native Python objects, dictionaries, lists, sets. Lots of objects have operations, some of these operations at least are operations like these. When we use custom methods and properties, someone has to learn what our class does. When we use operations or operators that are built into Python, people already know how those operators work on other data types, so they already know how they work on our data type as well. So in terms of details, this is how you would implement this on a class. I don't want you to worry about these details. I do want you to not be afraid of reaching for operator overloading when it makes sense. This is something you see a lot in third-party libraries. You can do this in your own code. I don't want you to abuse this. You can abuse this. I do want you to reach for operator overloading, or at least consider reaching for it when it makes sense in your code. If you're ever planning to actually make your own container type, ignore what I said before. Don't actually overload each of these operators yourself. Use one of these abstract base classes. It gets you quite a bit of the way there. It gets you 80% or 90% of the way done to making your own custom class that works like your own data structure. Let's talk about functions. So this code connects to an IMAP server. It connects to an IMAP server, which is a way of reading email, and it reads email and does some stuff with those email messages. So you might notice here that one of these functions returns a server object, and the other three functions each accept a server object. This should be a hint that something weird is going on. We've got a lot of repetition going on in our code. What could you do if you've got lots of functions that all take the same type of data?
Class.
Yeah. Whenever you've got lots of functions that all take the same object, you should think of making a class. This is exactly what classes are designed for. Classes bundle up functionality and data and allow those to be coupled together. We've tightly coupled some data, which was that server thing, and some functionality, which is each of these now methods that were functions. There is a talk called Stop Writing Classes. It's the opposite of what I just told you. That's mentioned in my notes afterwards. You can watch that on your own. Classes are abused, especially if you're coming from an object-oriented programming background. If you don't use classes, you can also underutilize them. They are useful tools. Okay, so brief recap. When you find yourself wrapping code in redundant try-finallys or try-except blocks, consider using a context manager to make your code, to abstract away some of those cleanup steps that you do over and over in your code. When you are making one list from another list, taking an old list, making a new list out of it, use a list comprehension. When your objects look like a container and act like a container, look like a dictionary, act like a dictionary, look like a list and act like a list, you should consider using operator overloading and making your own container type, or inheriting from one of the built-in container types. Do not be afraid of using dunder methods in your code to make your own container types. If you have a specific problem, use a specific solution. So recap of the whole talk here. When you are writing code, stop to pause every once in a while and actively consider the readability of your code. You can use this checklist here as a starting point for your own reflections on your code. Your computer's battery is about to die, so I'm going to speak really quickly here. As you use this checklist on your code style, you will hopefully start to build up a code style guide as you think critically about your own code style and what it is that you really prefer. Remember that every project that you have should have an explicit code style guide where you document all of your preferred code styles. The more decisions that you can offload to a code style guide, the fewer you will need to keep in your head, and the fewer you will need to assume that other people can infer from your code. The less out-of-band information that you'll have. One last thing, if you're curious about my own style guide, this is a URL that points to it. It's not very complete, but I do have a style guide of sorts for Python code. This is my style guide. It is not your style guide. You're welcome to adopt my style guide, but I would recommend that you write a style guide that reflects your own code style. Here's a list of videos. I stole a whole bunch of ideas from a whole bunch of talks that I've watched in the past. Much of my learning of Python has come from pyvideo.org, which is where I found these videos. You can search for these afterwards. I'll put the URL for the slides on the meetup event. I'm happy to take questions, or we can just mingle afterwards. Yep.
How do you feel about using list comprehension to mutate the elements?
Don't use a list comprehension to mutate elements. That is how I feel about that. List comprehensions, they should never have side effects. So don't print in them, don't mutate things. Anything that's a mutation shouldn't go in a list comprehension. It should be in a for loop. Yep.
Your operator overload example, did it show how to actually define how to overload the plus sign, or is that something you have to
yeah, it did. However, you should look that up yourself because it wasn't very comprehensive. Where was that? That was here. So these abstract base classes, they will help you do that. This here, the plus sign is dunder add. It's its own dunder method. There are a lot of dunder methods.
Okay.
But yeah, these dunder things, it's the protocol, the contract between you and the Python interpreter that allows you to overload operators in Python. Other questions?
Is it a personal preference to remove the parentheses in a tuple, or is either?
Yes. And in fact, I remove them sometimes and don't remove them others, and that's actually missing from my style guide. So I should probably think critically about when and how I do that and put that in there. But yeah, I tend to not use parentheses for tuples with multiple assignments. I don't when they're on the left side of an equal sign pretty much ever, unless it's deeply nested. Otherwise, I usually do, unless they're on the right-hand side of the equal sign and they're the only thing. I think that's the way I do it, but there might be some more thinking and introspecting I need to do. I think there was another question. I don't know if...
I have a question. What if you return that comma from last parameter
oh, yeah, so when I did... Oops. Here. Yeah, that trailing comma. So the reason I do this trailing comma, the reason I like that, this is actually legal. This is valid Python code. If I swap these lines around, it might break if I didn't have that comma. Not only that, Python has something called implicit string concatenation, which is a bug waiting to happen. It's not on this slide, I can't explain it, but that trailing comma can stop some bugs from happening in your code. So I tend to consider that comma as something I put after everything in my code if I'm on multiple lines. If this was on a single line, I don't do a trailing comma. Other questions?
Take the other, put over somewhere else. Top Python, but I think
Yeah.
also they mentioned something of having that, which I also like to just remind myself that if you do add something to the bottom, that because you always are used to adding that comma, that you don't forget something. You love it, that you don't forget to add that comma.
Right. I think, was that the interview with Dan Bader on Python Tricks? Yeah, that was a good one. Yeah, if you're not subscribed to Python podcasts, there are podcasts that they talk about Python. So it's pretty fun. If you're not in a podcast, it's worth thinking about getting into. Other questions? So another little pitch for lightning talks. My speaking experience comes in almost entirely from doing lightning talks at pretty much this meetup. So give a lightning talk next month. Talk to Diane. A 5-minute talk goes a long way to helping you become a better speaker.
Woo!
You will live through it. No one's died yet, at least. Yeah, which is good news. Thank you.
Thanks, guys.